Hello everyone, welcome back to SimpleGAN. Look around you right now. The tires of your car, the seals in industrial pumps, conveyor belts in factories, shoe soles, medical gloves, cables, hoses, and even vibration dampers. What do all these have in common? They are made using synthetic rubber. But have you ever wondered, how is synthetic rubber actually manufactured? What raw materials are used? How does it differ from natural rubber? In this video, we will clearly and step-by-step understand the manufacturing process of synthetic rubber, from raw materials to final rubber products. So let's begin. Synthetic rubber is an artificially manufactured elastomer produced using petrochemical raw materials instead of natural latex obtained from rubber trees. Unlike natural rubber, synthetic rubber has controlled properties, performs better at high temperature, resists oil, chemicals, and aging, can be customized for specific industrial applications. Because of this, synthetic rubber is widely used in automobile, power plants, steel plants, refineries, and heavy industries. The primary raw materials for synthetic rubber are petrochemicals, mainly obtained from crude oil and natural gas. Common monomers used: butadiene, styrene, isoprene, chloroprene, acrylonitrile. These monomers act as building blocks. For example, styrene plus butadiene SBR, butadiene polybutadiene rubber, chloroprene neoprene rubber. The manufacturing of synthetic rubber is based on a chemical process called polymerization. What is polymerization? Polymerization is a process in which small molecules called monomers chemically join together to form long-chain molecules called polymers. These long chains give rubber its elasticity, flexibility, strength. Now let us understand how this happens practically in factories. Raw petrochemicals are processed in refineries and cracking units. Required monomers like butadiene or styrene are purified. Impurities are removed to ensure uniform rubber quality. There are three main polymerization methods. Emulsion polymerization. Monomers are mixed with water, emulsifiers, catalysts. Reaction occurs in large reactors. Temperature and pressure are strictly controlled. This method is commonly used for SBR rubber, which is widely used in tires. Solution polymerization. Monomers are dissolved in a solvent. Provides better molecular control. Used for high-performance rubber. Gas phase polymerization. Less common. Used for special rubber grades. After polymerization, rubber is present in liquid latex form. Coagulants like acid or salt are added. Rubber separates as solid particles. Rubber is washed thoroughly. Removes unreacted chemicals, soap residues, improves aging resistance and durability. Washed rubber is passed through dryers. Moisture is removed. Rubber becomes solid and elastic. Dried rubber is compressed into bales, packed and sent to rubber product manufacturers. Raw synthetic rubber cannot be used directly. It must be compounded with carbon black, sulfur, accelerators, antioxidants, fillers, and plasticizers. This compounding is done using two-roll mills, internal mixers like Banbury mixers. Vulcanization is the most important step. Rubber is heated with sulfur. Crosslinks are formed between polymer chains. Rubber becomes strong, elastic, heat-resistant, wear resistant. Without vulcanization, rubber would be weak and sticky. SBR, used in tires and conveyor belts. MBR, oil-resistant, used in seals and hoses. Neoprene, weather and chemical resistant. EPDM rubber, used in roofing, gaskets, automotive seals. Butyl rubber, excellent air retention, used in inner tubes. Synthetic rubber is used in automotive tires, conveyor belts, pump seals and gaskets, vibration dampers, electrical insulation, medical and safety products. In heavy industries and plants, synthetic rubber plays a critical role in reliability and safety. Consistent quality, better oil and chemical resistance, longer service life, less dependency on climate, customizable properties. So friends, today we learned what synthetic rubber is, raw materials used, step-by-step manufacturing process, compounding, and vulcanization industrial applications. Synthetic rubber is a perfect example of how chemical engineering and material science support modern industries. If you found this explanation helpful, please like, share, and subscribe to SimpleGAN. Comment below, which industrial rubber application do you want next? Until next time, keep learning, keep growing with SimpleGAN.